talk about something really important. Okay, it's called factorize by completing the square. Okay, we all know completing, like we know how to completing the square from last year. I hope. Okay, I hope. I'll go through that again with you anyway today. Ask you a question. Do you think all the quadratic equation can be factorized on, like, do you think all of them can be factorized or not? Give you any quadratic equation, do you think it can be factorized? So, okay, even using complete square, do you think all of it can be factorized? Do you think all the quadratic equation will get a factorized form? That's my question. Say ax squared plus bx plus c, everything can be put into bracket x plus something or x minus something. Do you think all the quadratic can be put in that form? Okay, let's just think about this question and let's go through complete square first. Go back to the previous exercise. Do you think all the quadratic can be factorized by this method? Is that true or not? No. Okay, it's no. Because, for example, I give you something like this. This one. It can't be factorized by that. Okay, 8, a positive 8, like a positive 8, can only be 1 8, 2 or 4. Okay, there's no other combinations. It's not going to create a negative 2 for you. It can create a positive 6. Okay, it can create a positive 9, but it can't create a negative 2 for you. Because I need a negative 2. If that's a minus 8, that will work. Okay, if it's a minus 8, 1, 1, minus 4, and 2, that will give me a minus 2. But a plus 8, well, they're either both positive or both negative. It can't give you the 2 in the middle. So, obviously, not everything can be factorized by the method we learned in the previous exercise, like I call that cross multiplication. So today we're going to talk about like how to factorize all the quadratic by one method. Okay, it's called completing the square. So if we think about the example here, okay, complete square means I want to put things into the perfect form, perfect square form. So what we have is x squared plus 8x. Okay, so you can think that as a squared, and the middle term is 2ab. Okay, 2ab. So what is b? What is b? A equals to x already. So b will be 4. So b equals to 4. In this case, we can see that. So we need to add a 4 squared. Like we need to add a b squared. So which should be a 4 squared. To complete square, I need those 3 terms to complete the square. Because if I have x squared and I have 8x, and if I have another 4 squared, that will give me x plus 4 squared. Okay, so a squared, b squared, and 2ab. So how do I get the 4 squared? This 4 squared is get from the middle number divided by 2 and then square it. But we just create a 16, okay, from nowhere. Like I just add a 16 on that. That's not good. So I need to minus exactly the same thing again. Okay, so I add a 16, not good enough. I will minus the 16 down to still make it balanced. Still exactly the same thing as before. And then don't forget the minus 3. The minus 3 is still here. Then what I will have is the first 3 things can factorize and can complete the square. That is the x plus 4 squared. And what constant we left here? That is a minus 16 minus 3, which is a minus 19. Okay, which is a minus 19. Now this minus 19 can take a square root. Make a square root 19 squared. Okay, square root 19 squared is still 19. Now I can use the a squared minus b squared formula to factorize it. Okay, to factorize it. So it's x plus 4 plus square root 19, x plus 4 minus square root 19. So that's what we will do. But I'll ask you a question. If here is a plus 19, this if, okay, if say this part is a really large number. Let's say it's a plus 17. Okay, if the minus 3 is a plus 17, so we will have a plus 1 here, okay, instead of negative 19. Can I still factorize it? X plus 4 squared plus 1. Can I still factorize? How? Can I still use a squared minus b squared formula? No. Is there any other formula I can use? A squared, well, it becomes a squared plus b squared case. The answer is no, okay? I don't have any formula. As I said in the first exercise, we only have a squared minus b squared can be factorized. A squared plus b squared cannot be factorized. So if this number is not a negative something, if it's a positive something, this cannot be factorized. So I write it here. X plus 4 squared plus 1 cannot be factorized. Okay, now I will make this statement. Completing square is not a method that can factorize all the quadratic equations, but it's a method to check whether this quadratic can be factorized or not. Okay, for example, I complete a square and I have this result here, which means it cannot be factorized. Okay, not all the quadratic can be factorized. Okay, something you need to know is not all the quadratic can be factorized. Okay, so we can use completing square to check. There's a better method we can check it later in the exercise, we'll learn that. But like so far, we can use completing square to check. If we have something squared plus a, like x plus or minus b, h, let's say h squared. If I have a plus k, cannot factorize. If is x plus minus h squared minus k, then it can be factorized. Okay, it depends on after the completing square, what form do you have? Do you have adding a constant or do you have subtracting a constant? If you have adding a constant, this quadratic just cannot be factorized. If you have subtract a constant, then it can be factorized by using a squared minus b squared formula. Okay, that's something we need to understand. That's really important. You should understand not all the quadratic can be factorized. Yes, not all the quadratic can be factorized by cross multiplication, but it might be able to be factorized by completing square. But after we do completing square, if we still have a plus constant like this, this definitely cannot be factorized. This definitely cannot be factorized. So completing square is more like something we can check. Okay, we can check whether this is true or not. Okay, can be factorized or can't be factorized. And to write another thing here, to complete square, we can only do x squared plus bx plus c. When we have ax squared plus bx plus c, which a is a number like 2x squared plus 5x minus 1 or something like that, take common factor first. To make it ax squared plus b over ax plus c over a. Okay, we complete the thing inside. Okay, we can complete the thing inside. like ignore the a. Okay, we only complete a single x squared plus bx plus c. So let's try a question. Okay, let's try a question. Let's have a look at the first one. Okay, let's have a look at the first one. Let's do B. Let's do B. A is easy. Let's do B. B is x squared plus 3x plus a half. Okay, x squared plus 3x plus a half. What's the method to complete square? We just copy the x squared term and then the bx term, and then we will add half of the b squared and minus exactly the same thing. Always plus first and then minus. Okay, you always plus first, the plus 3 over 2 squared and then minus 3 over 2 squared. And then plus a half. Well, the half is originally what you have. So those two terms can be cancelled. You still have the same thing. But I can complete the square by those three. The first three terms will complete square. And the last two constant just involve like calculations. So what I can do to complete square, I will take the x always from the first term. Take the sign from the second term. Take the number from the third term. So what I will have is the x plus 3 over 2 squared. Okay, we put that in the bracket. We take the x, we take the plus, and we take the number. We take the x from the first, we take the sign from the second, and we take the number from the third, and put them together into a square. Okay, bracket them and squared. And then we calculate whatever we have. At the back is a 9 over 4. And I can plus a 2 over 4. Okay, half is 2 over 4. So I have completed square. That's a minus 7 over 4. This is called complete square. Okay, this is called complete square. And here means it can be factorized. Okay, something squared minus a constant, that means it can be factorized. If it's a plus, it can't. But if it's a minus, it can. So what I can do after that is make it a squared minus b squared form. That's a minus root 7 over 2 and then squared. A squared minus b squared. So what I will have is x plus 3 over 2 plus root 7 over 2, x plus 3 over 2 minus root 7 over 2. A plus b and a minus b. Okay, just show you the full working for that. Have a think about what we have done. Okay, let's have a think about what we have done. Okay. This, can you see the first three questions, A, B, and C? They are all with a single x squared. I think they all can be done by the same method. But let's have a look at the next one. Okay, let's have a look at D. For D, we have a coefficient for x squared. What we should do, you need to be very careful with this. Okay, I see a lot of students still get this wrong, even their year 12s. When there's a coefficient, they always forget the bracket. So I'll just show you where is the common mistake place and pay attention to that. So first of all, I can't complete square with the A there. So I'll take the minus 2 out. Okay, so that's the x squared plus 2x and then minus 5. Okay, that's how I can factorize it. And then the next step, well, I don't need to care about the minus 2, but this needs to stay there. Okay, there's a minus 2, but I don't need to worry about that at all. So I will keep the first two terms, okay, it's x squared and the bx. Then I will half of the b value, so it's 2 over 2, and then squared. And minus exactly same thing. So I know it's a 1, but I just write this for you to think about. And then you still have a minus 5. Then I can complete square. Okay, we take the first term x, second term sign, and third term number. We put it together and then we put it in a square. Minus 4 minus 5, that's a minus 9. No, the minus 1 minus 1 minus 5 is a minus 6. Can you tell me, is that right or wrong? Yeah?
You gotta have the bracket.
Where I should have the bracket?
Around x plus 1 squared minus 6.
Yes, good. That's the place that I see a lot of year 12 students make mistake. There's another bracket. This bracket is the new bracket you create. Okay, it's the new bracket you just create by using the first three terms. Okay, you create another bracket, but this original bracket is still there because you haven't times the constant inside with the negative 2 yet. So you need the bracket. Okay, you need the bracket. When I expand, okay, when we look at this, there are two ways. Okay, I need to know how to expand. I also need to know how to factorize. From this step, let's go for two parts. Okay, one is expansion. Because it's the turning point form later we'll learn. When we expand this, this becomes minus 2 x plus 1 squared and plus 12. Okay, we have that. That's called the turning point form. I'm not sure if you learned that last year. You should learn it in year 9, maybe. Turning point form. We will learn that later. Okay, not now, like not this semester, but next semester. But this is the turning point form. We complete square and then do all the expansions. But another thing is, in the bracket, okay, before you open the bracket, can you see the sign here? This means can factorize. Okay, this means can factorize in the bracket. Okay, I don't need to care about the negative 2. Put the negative outside. I just factorize the inside. What I will have is that equals to minus 2. Well, I put a square bracket here. So x plus 1 squared minus root 6 and then squared. So that's minus 2. And I have x plus 1 plus root 6. X plus 1 minus root 6 squared. And I don't really need the square bracket because they are all times relationship. So I can just get outside. Oh, for this question is factorize form. This question asks you to factorize, but like this is just prepare for later. When we expand, we have turning point form. Okay, so that's D. I'll do one more with you. I'll do F with you, okay? So 3x squared minus 2x plus 6. If I were to do this, I need to take the 3 out. So it's a 3x squared minus 2 over 3x plus 2. So in the bracket, I keep the first 2 terms. What's the half of b value? Well, our half of that value. What's half of that? Simplify. When you can halve the numerator, you halve the numerator first instead of times by half. Like, so 1/3, right? Half of it is 1/3. So half of that squared. Don't forget the squared. So you half of that squared, and you minus half of that squared. And then remember the plus 2. So remember the first 3 can factorize, always plus and then minus. And the last 2 will be calculated. Okay, remember there's still a bracket here. Okay, there's still a bracket. This bracket is still stay. And I create a new bracket. So how I can create a new bracket? First x, second sign, and third number. So I have x minus 1/3 squared. Minus 1 on 9 plus 18 on 9, which is a 2. And that is 3x minus 1/3 squared plus 17 on 9. Can we factorize? No. Okay, we look at the sign, it tells us cannot be factorized. Okay, we don't have a squared plus b squared, so that means cannot be factorized. But I can still make it into the turning point form. I can expand. That's 3x minus 1/3 squared plus 17 on 3, not on 9. Okay, so this is the turning point form. Okay, any questions for turning point form? If no, okay, what I want to do is you complete these 3 questions. Come here and pick your exam paper away. Okay, I'll wait here. You complete the 3, come here and I'll give you your exam papers.